Good evening, everybody. Welcome to the Triangle SQL Server Users Group's Advanced DBA subgroup. This is our February 2020 meeting. Tonight, we're going to have Grant Fritchey talking to us all about execution plans, diving into that. Before that, I have two brief announcements. Number one is SQL Saturday Raleigh is official. It will be April 18th, 2020 at Wake Tech RTP, so right in the heart of Morrisville. Registration is free. There's an optional $15 lunch. Go to sqlsaturday.com/981. That'll help you sign up there. Also, if you're interested in speaking, our call for speakers is still open. So get those submissions in. We're in until the end of the month. And then we're going to pick speakers and get moving with the rest of the bits there. The other announcement, Analytics Forward is coming to us next month, March 14th. That's a Saturday, at SAS Hall and Stinson Drive, Raleigh. So this is hosted by Research Triangle analysts. It is a really cool unconference where there's no announced sessions. People come in, they decide that they want to present something, throw it up on the board. If you get enough votes, you're on the schedule. So it's an interesting idea. It is $12 for admission. If you're interested in that, I'm going to post on our meetup on TriPass a link over to RTA where you can sign up for real. We won't actually have anything to sign up for real, so please, if you do want to go to RTA. Those two announcements aside, I'm now going to hand it over to Mr. Grant Fritchey.
Thanks. All right, I assume you guys can see the title slide?
Yeah.
Cool, let's get going. All right, so the goals here are to talk about execution plans. But really what I want to talk about is execution plans. I'm not going to talk about query tuning, performance tuning. Seeks are good, scans are bad. I want to talk about some of the stuff that SQL Server exposes through execution plans, because there's a lot of detail in there and there's a lot of behavior, and it's really good to understand what these things are showing you, because it gives you a better way to interpret what's happening when you open up your own code. So that's the goal here. Hopefully we'll hit it. What I've got here is a detailed, precise picture of the query optimizer. Now this is the advanced query optimizer because it's got the red light on it that lets you know when it's finished. But the fact is that the query optimizer, the query optimization process is a black box. It is just this invisible thing. Stuff goes on, and unless you're, Paul White and you're running the debugger to understand precisely the things that are happening, there's just this, queries go in, stuff comes back out. What the heck happened in between times? Well, who knows? So, I mean, it's this odd thing that we are completely dependent upon this utter mystery in our midst. So let's talk about it. So the thing is like execution plans are, okay, there are one window into the optimizer, right? So that's why we're going to look at execution plans, because they give us that view into the optimizer. They give us that idea of what's going on, what is here, what can we see, and what is happening. It gives us an indication of how is our code being used, right? What is happening within the code? What sort of things are there? Are we, what are we seeing, and how is it behaving? And it tells us which objects are being used, and therefore, are we using a particular index? Are we using a particular set of statistics? How was that index used? How were those statistics used? Or heck, was that object used at all? Did it reference the thing I thought it was going to reference? I mean, I put in for a query and I got something back, and I don't know exactly what happened. So, I mean, execution plans are, they're there for these things, but what else are they there for? I mean, that's always been like my question is, is there more to it than just simply query tuning? Now, I am legally obligated to say that, when you're doing a select and an insert or a delete statement, that the best way to tune your queries is to talk about looking at execution plans. It's the standard method. It's the one thing everyone expects. And oh my God, it's so dull. It is so incredibly dull sometimes. Yeah, okay, cool. We're going to tune the query. Yeah, okay, cool. Let's go look at the execution plan. But, let's meet the legal obligations. Let's talk about the fact that, in fact, when you're looking at a query, like this one, where we're joining against a couple of tables, we've got a where clause. It's nothing crazy. It's nothing complicated. If we're to run this query and capture an actual execution plan, and oh, by the way, you do realize that there is only one kind of execution plan. There's an execution plan, and there's an execution plan plus runtime metrics. That's it. The execution plan never changes. It's only the addition of runtime metrics that turns it into this horrifically named actual execution plan. But we're going to go ahead and use that because the runtime metrics, which is what we're really excited about, are useful. So let's go ahead and execute this query. We get the runtime metrics. Here is our execution plan. Let me zoom it up. Cool. So, it's a nested loops join. It's pulling from a clustered index seek and another nested loops join, and a clustered index seek and another nested loops join, and it's got a filter operator in there, which is, some percentage of the cost, and then it's got a clustered index scan, and it's a higher percentage of the cost. Seeks are good, scans are bad. There is your execution plan. It's boring. It's just dull. And also, it's a lot of lies. It's a big bag of lies, really, because it's telling us of cost estimates. And, this is quote unquote an actual plan, but those cost estimates are still just the same estimates because this is still just the same plan as if it was a quote estimated plan, because there's only one kind of execution plan. But regardless, okay, let's do query tuning, right? How do you fix all queries? You create a new index, put a couple of includes on there so the index is covering. And now when we rerun our query, we'll wonder if wonders never cease. Our execution plan has changed. Instead of 2 compute scalar operators and the filter operator and a scan, we're now down to just the single compute scalar operation, and all index seeks and all nested loops joins. And oh my gosh, I'm a hero. Boring, 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 boring. Any questions? Cool. Let's go start looking at what else we can do with execution plans. Oops. Come on. There we go. So first up, execution plans gives us a way to look at views. And so there's a lot of fun stuff we can start looking at. We've got your traditional view, which is, again, just a query. Never, ever, ever forget that. Lots of people get into their head that because a view looks and acts like a table, that it somehow is persisting information. It is not. We do have materialized views, also called indexed views, and those things, in fact, do move data. That's why they are different. They're not really views, though, because what they are now is a clustered index. And what's a clustered index? A table. So we're creating this second table, and this second table is linked to a query, and it feeds its data in and out through this query. And so it's a little weird in that, but it's still just a view. Now, these things have limitations. You've got to make sure you've got ANSI nulls on, ANSI warnings on, concat null, yields null, ANSI padding, arith abort, and quoted identifiers. In other words, you have to have all of the ANSI standard settings in a positive fashion. They all have to be switched on before you can start using them as materialized views. But once you use them, then the optimizer gets excited because it can do all these weird things where it will sometimes not expand that view. It will see that as strictly a table. It will access it as strictly a table, and it won't treat it as a query. But in other cases, it will expand the view. It will look upon it as a query, even though it references the data from that materialized view instead of from a regular view. And it can go off and do weird things. Further, you've got query hints that can allow you to force it in one direction or another. And all of these things are exposed through the execution plan. And now finally, the one thing I do like talking about in views is the concept of simplification. Now, a lot of people get excited when I start talking about this because everyone wants to just create a view and then create another view and then have those two views joined together. And then once those two views are joined together, you nest them inside another view, which joins to other views. And then all the views are connected together and they just go down like a horrific rabbit hole. But hey, SQL Server has this thing called simplification. And in simplification, SQL Server will attempt to eliminate the tables that you've put into your view that are no longer needed to satisfy the query that you're running. And so you can run this query, and even though it's hitting 20 tables in the view, SQL Server will get it down to the correct number of tables. Well, yeah, but it will try to do as much simplification as it can. But here's the deal. The more time it's spending doing simplification, eliminating tables, figuring out ways, well, hang on, they wrote this query this way, but really what they mean is this. They wrote this query this way, but really what I should be referencing are these tables. The more time it spends cleaning up the mess, the less time it spends optimizing. And therefore, you get execution plans that suck. So this is one of the issues with views, is because they look like tables, because they act like tables. You're going to see a lot of people think they are tables, and they're not. But let's take a look at what they do inside of an execution plan, because that's what we're here for. All right. So here's a standard view. I'm going to pull off a couple of tables, a few columns from it, from the human resources table, and we'll just take a look at the regular, again, at the query plus the runtime metrics. And so the query is shockingly very similar to the one we just ran because I stole the code. So you can see that this looks a lot the same. It's got the same stuffs going in there. And there are how many tables? 1, 2, here, let's just zoom back out so I can actually see. 1, 2, 3, 4, 5, 6 tables referenced in this view, even though the query looks like it's only pulling from a single location. But you know what? Let's take a look at the actual view itself. Let's just do a select star. So we're eliminating the concept of simplification from this and see what we've got now. Now, first thing to notice is that obviously the query that makes up this view is very different than what the optimizer did to satisfy my first query. Because instead of, what was it, 6 tables, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it did some simplification. It was able to identify that even though there's 9 tables included in the view definition, it only needed to do 3. Now, here's the fun thing. If we go back and take a look at that other plan again, there's not a single indicator in here that it's done simplification. And there's no way to tell that. It's just part of the optimization process. It's something you can sort of kind of count on, but you're never going to get the best possible thing you can get out of it. It's only going to be able to do what you told it to do within the parameters that it has. And if you look at it, the one thing you should always do is have your properties window pinned open, because this is where all the details are. This is where all the information that when you're reading execution plans, this is where you want to go to understand information about these operators. Sure, you can tell that, the estimated was 1 row, but it actually returned 36. So there's a 3,600% difference in the way this thing behaved, but that's not all the details. The details are inside here. What was the object? What was the number of rows read? How many executions did you have? What is the node ID? What is the cardinality of the table? All of that information is captured inside there. A little bit of it is captured in the tooltips, but the tooltips are hard to read. They're hard to control. I wish they would just let us turn them off, because all they do is get in the way. If you know all the detail is in the properties window, you open the properties window and off you go. You keep going. Now let's keep going on views for a second. If we take that same view and just add a where clause, the execution plan changes again. Now, because I did a select star, it does look a lot more like that other plan, right? Because we're taking it down to the same number of rows. But by doing a select star, I'm getting every column. So therefore, there's no chance for it to do any kind of simplification. So the entire broad scope of the view is brought back. If anybody ever needs an excuse for not doing select star as a default behavior, this is one reason. I'm not adverse to select star, but it's not a best practice. It's not a good approach. And you can see why, just based on the behavior of this really simple little execution plan from this really simple view. This is before we get into anything even remotely complicated. Everybody cool? Questions so far? All right, let's take a look at a materialized view.
We actually do have a couple questions.
Okay, cool.
So I would have thought that one of the things that you would want to do by default is do a select star on your view, so that you can then slice and dice it with your select statement, and not just replicate select star when you're accessing the view. So could you explain where you would put explicit column names on views as opposed to doing select star on your in the view itself?
Well, in the view itself?
Yeah.
Well, in the view itself, I mean, you should just be defining, I mean, let's take a look at what this view definition is. I actually don't know off the top of my head, so let's take a look. Which one am I doing? View product, no, that's the one down below. I think it's human resources view employee. 1 second. Oh, I clicked the wrong button. 1 second. Ah, God. I haven't seen this window in a long time, guys. That's pretty cool. Anyway, sorry. It has been an age since I saw that. Neat. There we go. T-SQL, what a concept. All right, so this is the view. They're doing the same thing that I would have done. They're defining this view as a particular set of columns. They're very carefully defining it. It's going against a set of tables. You'll notice this looks, except for the fact that there's brackets everywhere, this looks like the query that we started with, largely because it is the same query. I pulled it out so I could use it as an example in behavior. But I'm not sure I understand the question. I would write the query this way. I would not write select star inside the view. I would only pull the columns out of the tables that I want to define the shape that this view represents. I mean, because that's the whole idea of a view is that you're pre-shaping the data. If you're not going to pre-shape the data, why would you create a view at all?
Views maintenance versus performance.
Yeah. Maintenance versus
memory usage in terms of data. You're doing it.
I'm not. I truly don't understand where you're going with it, because I mean, a view's just a query. I mean, and depending on how you query the data, it will use more or less memory, and defining it to return all columns by definition, because it is just a query, it won't use more or less memory in the definition. Well, okay, it will use slightly less memory in the definition, because the memory taken up by defining these column names. You would eliminate that by putting in star. But I mean, that's it. I mean, and that's a trivial savings. I mean, that's what, 50, 100 bytes. Even if you add that up over millions of views, and why would you have millions of views? But it's still, oh my God, the comma's in the wrong place. But anyway, it's you know, I'm just not sure where we're going with that, because it's not something I would do. I would define this for the columns we need. I mean, the whole idea of a view is to shape a query, pre-shape it, really.
So if you needed different columns, then you would have to go back and change the view.
Yes, or something else. So, okay, I see where you're going with this. You're trying to get to code reuse.
Yes.
Oh, cool. Yeah, we don't do that in SQL. Yeah. Yeah, oh no. This is a declarative language. We don't do that crap. Code reuse, and honestly, your sentiment is correct. You are trying to do the right thing, but SQL Server is not here to help you, and T-SQL is not here to help you with that. Code reuse is actually a big bugaboo of mine. I push people off of it. Most of your code, 90% or so, should be generated using a tool. You shouldn't be writing it. You should only be writing about 10% of your code, maybe even 5% of your code. And yes, I am suggesting using an ORM or some other similar thing. But you should not be writing most of your code, so you shouldn't have to worry about code reuse, because you should be letting it get generated for at least 90% to 95%. But the problem we have is the optimizer hates code reuse. Everything you do to facilitate code reuse makes the optimizer's job harder and harder, because it has to work more to try to eliminate the stuff that you don't need, because you've built this giant thing using code reuse. I mean, I'm going to get to an example here in a little bit that addresses this further. But yeah, I would just get that out of your head when you're working with T-SQL. Don't try to reuse the code.
What about the query plan reuse?
Sorry?
Query plan.
So the question was,
Somebody repeat.
what about query plan reuse?
Oh, well, query plan reuse is different. Now, the thing to remember about views is it is a query. And if you write select star against the view, that will create a plan, and then that plan can get reused. But most of the time what you see in somebody is they'll do what I did, which is, I want to select these columns from this view and these columns from this view and put them together. That's one plan. And then they use the same views for different columns, and you get another plan. There's not a plan for the view and then that plan gets reused. What it is there's a plan for the query against the view. And so every time that we've run every one of these queries that we've run, you've noticed there's a new plan each time. The way I've set it up is I have had at least 3 different plans so far that we've looked at, and the 3 plans are based on 3 different queries. So, and if we make changes to it, if we add some difference to the where clause, even though it's the same view, or we add another column, even though it's the same view, we will get a new execution plan. So views are not going to somehow lead to plan reuse. Isn't that fun?
Michael, one more question.
I was more simple. So select star negate simplification. Did I get that right?
Yeah, select star completely negates simplification, because there's no way for it to eliminate anything, because you've told it to bring everything back.
That's when you're consuming the view.
Yeah. Exactly. Cool. Well, let's take a look at, let's make it harder. Let's take a look at materialized views. So this is built into AdventureWorks. This is a materialized view. And to take a look at the execution plan, it doesn't look like one. Instead, it looks like a regular view. The query we ran should come back as, you know, a view, but it does not. So what we're going to do is we're going to force it into a plan hint. and run it that way. And now we can see that it's not expanding the view. Therefore, we get a look at, hey, this is what it really did. What it really did is it went against this thing, V product description, which is a single table. It is not a query, but the definition of the view that makes it into a materialized view is dun, da, 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 a query, and that query gets expanded by the optimizer, and it takes a look at all this stuff and brings all these things back. And by the way, because I'm doing select star and I don't have a where clause, which is why it did this by default. Again, I like to cheat a lot to force behaviors, but this is something you should see on a regular basis. But if we really do the queries the way you're supposed to, so we're taking a look at this query and we're going to execute it. The execution plan comes back, and this time, because we've done all kinds of fun stuff, it knows that the information that I'm going after here from the person, state, province, and the person, country, region are actually contained in the V product description table. And so expand, not expand, it actually said, well, heck, I can just use this materialized view and retrieve this data. So now we can force it to go the other way. We can tell it, hey, you know what? Don't help me. Stop helping me. Stop making things better, and show me what the actual query would be. And then it forced the expand, and it then shows you what the actual execution plan would be for the query if we were not taking advantage of the materialized view. Life is awesome. Any questions on those things?
We do have a question, yes.
Sure.
Grant, what puzzles me here is that you didn't define the materialized view in here. You're telling me that the optimizer was able to sniff out that a materialized view existed and satisfied the condition to select and use that.
Yes. Isn't that cool? It can actually do that. It's not perfect. It's not going to happen every time. You can't just materialize view a bunch of your tables and walk away a winner. I had to experiment to get the right query to retrieve stuff. A where clause would have helped. It would have brought back better than just doing the without the where clause. But I try to make developers comfortable, so I write lots of queries with no where clause because they feel better that way. Come on, that's funny. Anyway, yeah, it can discover, and it did in this case, that there is a materialized view that satisfies the query. So therefore, it doesn't go against any of the tables. It just goes straight to the materialized view. And yes, by the way, performance for this query is superior, if we care about performance. Cool. Let's talk about something else. And remember, this is a weird presentation. That's the best way to put it. Because I know you guys are the advanced group. I'm not sweating all the details on reading execution plans. So here's a fun bit. Foreign keys. Now, foreign keys, enforced referential integrity, and the enforced is the important part, right? Whether it's trusted or not trusted really, really, really matters. If we have keys, if we have foreign keys and they are enforced, the optimizer gets to use them. And it gets to use them and make decisions that are going to affect overall behavior, performance, and the execution plan. And the only real way to explain this is to show you. So what we're going to do is I'm going to begin a transaction. I'm going to insert data into the address table. That's 1313 Mockingbird Lane, Springfield. And if you're really old, you get what I'm talking about. Now, this query was a single insert into one table. But if you take a look at the execution plan, I have got a constant scan over here on the right, which is the beginning of the physical processing. I I've got an assert operator over here on the left, which is the beginning of the logical processing. And then right here in the middle, even though it's a single table, I've got two tables being referenced, one with an insert and one with a clustered index seek. So what the heck is going on? Well, the columns that I wrote data to have an enforced referential constraint on the state province table. So trying to insert data into this address table had to reference another table. And so the way it referenced it is it does a seek against that table, and we can take a look at the predicates even. Get the predicates up so we can see them. Come on, where are they? Where's my little ellipsis? What's going on? SQL Server's being mean to me. There it goes. So if we take a look at it, the reason I bring it up just makes it easier to zoom in. If we take a look at it, we've got the seek keys are the scalar operator of the state province ID compared to the state province ID. So it is literally looking up the value to ensure that that value is there. It's then doing a nested loops join to bring it back together. The nested loop join has an expression 1015 that it's spitting out. We can see that over here. And then the assert operation has a predicate. Let's look at that. When expression 15 is null, then 0, else end, else null end. In other words, if the value exists inside of the table that it just looked up and did a nested loops against, keep going. If that value did not exist, assert 0, which is going to cause this entire transaction to roll back because it's doing a whole rollback across this whole thing. Now, before we keep going, let me also introduce the constant scan for those who don't know. The constant scan, we'll use the tooltip, it's the same. Constant scan scans an internal table of constants. I hate Microsoft sometimes. I love them, but I hate them. A constant scan is a scan of constants. God, my English teacher would be angry. But here's the deal. What is it doing? It's outputting something, nothing that we can see. And it's doing a compute scalar operator, and that compute scalar operator is, let's get it open, is doing get identity. Okay, interesting. And the next compute scalar operator is feeding in a bunch of information, including a new ID. So what's going on? Well, what's happening is the constant scan is a placeholder for the data that we are going to add. And the first compute scalar operator is going to the table and getting the next identity value. Then it gets all the information, puts it into parameters, then it does an insert. And you can see, we can go in and look at the way it does it, but it takes the data that we fed it, it does an insert. After the insert, it does a nested loop join against the clustered index seek, against the state province table, and then it does a check to see if all of the values are correct. And if the values are correct, great, off it goes. If the values are not correct, it rolls back, and you just lost an identity value. Yes, the execution plan shows you why the identity values get lost, because it creates the identity first and does the assert second. And so if there's a rollback, you lose that identity value. It was going to be 1, but next time it's going to be 2. And you won't ever have a 1 because it didn't insert number 1 because it failed the assert. Well, I mean, not in this case. In this case, it went through, but you get the idea. Any questions on this on foreign keys? Because there's more foreign key fun.
I believe people are keeping their powder dry to inundate you with questions in a moment.
Cool. Now, if we do this, we try to do a delete. We didn't even get a delete because it immediately found that that interfered with what's going on. So let's instead, where is it? There. we can take a look at the estimated plan or the actual plan, or however you want to think about the execution plan. And in this case, what we see is when it's doing a delete, the first thing it does is does the delete. And then it does a series of validations. And then look, here's our friend, the assert operator. And what's the assert operator doing? A series of checks to validate that that stuff is there. And if it is there, it immediately returns an error. And that's why we couldn't look at an actual plan, because it already did all the work and it rolled it back. But if we take a look at this one, where I very carefully made sure that that value doesn't have anything in it, we get that same execution plan. And by the way, this is another indicator that the execution plans are the same. They're always the same. They're always the same. And we can also tell you that they're the exact same plan because it parameterized that plan through simple parameterization, and I can tell that by the @1, and that allowed for plan reuse. Haha, I love this job. Any questions on this bit of how the optimizer is dealing with and showing us how it's dealing with the stuff? All right, so now this is the fun part of foreign keys. Now, if we run this query, person address, 1 table, person business entity address, 2 tables, business entity, 3 tables, person, 4 tables. All right, so I am referencing 4 tables. I'm pulling P, last name, P, first name, and that's it. Now, 4 tables I am referencing. If we execute this and take a look at the execution plan, it's able to do simplification even on regular queries. It doesn't have to be a view for it to do simplification. So what it recognized was I was pulling back data that it did not need to reference all 4 tables. It could get that data by referencing 2 tables and did so. So that's an indication of simplification at work. Now, if we, oh, yeah, okay, hang on. I got to do this bit. I forgot to prep it. Hang on one second. Let me do this right now. One second, sorry. Now, if we run this query, this is against those tables you just saw me create. They don't have primary keys. They don't have foreign keys, let alone enforced referential constraints. Otherwise, it's an identical query. Everyone agree? Let's run it. Let's take a look at the execution plan. And boom. All 4 tables are being referenced. All 4 tables are being scanned. We're down to hash match joins, which are the best joins in the world because they cover all our sins. They are great. But you see the big, big difference here. Let's just put them both up side by side. If we give the optimizer tools like foreign key constraints, it can do more. Now, a lot of people argue with me on this one, so let's walk through it. We've got our tables. Let's alter them. Let's add primary keys because, obviously you're going to have primary keys on the tables. So we're going to add every one of these tables is going to make sure it has the proper primary key. Okay, so we're not dealing with all this goofy stuff where we had before. This is going to be an appropriate thing. We're doing the right thing. Oh, and by the way, this generates an execution plan too, if you're interested. And so now we're going to go back and run the same query against the my tables. And again, no simplification, no removal of the tables that are not being referenced. Why? Because there are no foreign key constraints that give the optimizer the capability to understand what's going on. Now, again, I get people arguing with me on this one. Okay, fine, Grant, you're running queries without where clauses. That's cool. Let's put a where clause on it. We'll run both of them side by side this time. And it didn't make any difference. I mean, yeah, okay, the plan shapes are slightly different. I've got a seek on one of the tables. on both places with the last name column, it was able to do a seek based on that index that had available. But on the one system, we've got all these scans going on, and yeah, it's doing merge joins, which are very efficient joins, but it's 4 times the amount of reads, right? Because it's hitting 4 tables with 20,000 or 20,000 rows each. And so it's going to make a big difference in the behavior of the query, let alone the fact of, that very simple query versus this much more complex query. Execution plan. The performance is going to be radically worse down here. And it's all because of the foreign key constraints, which the optimizer can use as part of its simplification strategy. And so, by the way, in your views, foreign keys are going to help you there too. Different discussion. Now, I'll bet there's a few questions. And yes, I just told you that foreign keys help performance.
I'm not seeing any questions.
Cool. This is the first time. Everybody always argues with me on the foreign key stuff. I love the foreign key stuff. They really are useful. I mean, it's that simple idea that it does things for you. All right, let's talk about how calculated columns work within the execution plans. Now, what you're going to see is you're going to see scalar operators. And scalar operators are going to have an extremely low cost or zero cost. The problem we have is that, how to put it, it's a lie. The thing is that there is a deferred execution that occurs inside the engine. And while we see a scalar operator and it's in a particular location in the plan, the scalar operator goes through what's called deferred execution. And deferred execution means it could be executed somewhere else. Now, where else could it be executed? Almost anywhere that can satisfy the query appropriately. But we're not going to know unless we run the debugger. So, because of deferred execution, oh, and by the way, did I tell you? These things are costed based on a straight formula. And that formula does not take into account the complexity of the calculation. So the calculation could be insanely complex or ridiculously simple, but the calculated cost is going to be the same because it's based on a constant. So this represents a seriously hidden cost that's going to affect us inside of our execution plans. The costs that are there get transferred all over the place. Other operators are doing work that you can't see. And so, and I'm not saying that don't use calculated columns. I'm not saying if you see these operators that you need to panic. You don't. I mean, they're fine. They're good. They're doing good work. But what you do need to be aware of is every one of those things is a little bit of a mystery. And so it's a good idea to get into the habit of like, wait a minute, it's doing a calculation. What does that calculation look like? And is it likely done where it looks like it's being done, or is it likely done someplace else? And if it's done someplace else, could it be inflicting pain upon me? And that's just all a judgment call you're going to have to walk through. All right, let's take a look at the code. Calculated columns. Now, if we take a look at it, we've got multiple, even though there's no calculations here in my query itself, right? Simple join, simple where clause, a few columns. The actual results that come back, on the execution plan, what comes back is I've got 2 compute scalar operators. So, best thing to do, let's go and take a look at them. Now, compute scalar operator number 1, or node ID number 9, however you want to think about it. It looks like it's just pulling data back. Oh, that's the output list, dummy. I'm an idiot. There we go. This compute scalar operator is taking the work order ID. It's doing a convert implicit. Wait, what? Yes, it's doing an implicit convert, and it's putting together the scrapped quantity value. And yes, that means the order quantity minus the scrapped quantity value. Those are not the same data types. It has to get converted to an int. It's a tiny int. Here's the good news. It won't affect optimization. I know that everyone talks about convert implicits dangerous, or an actual explicit conversions are also dangerous. But this is one of those cases where it's the movement is going from tiny int, I think, or small int to int, and that doesn't affect anything. So that's the good news. If it was something else, of course it would. Now here's the other compute scalar operator, and what's it doing? Stocked quantity is equal to scalar operator of stocked quantity as stocked quantity. So it's doing some sort of little calculation on stocked quantity that's a little confusing. We could look it up if we wanted to. But here's the fun bit. Is there, in the processing, when it does the select statement, says, hey, give me a row, the hash join table says, hey, index scan, do you have a row? And the index scan says, yeah, I've got a row, and sends it back. Then the hash joins says, okay, cool. Is that all your rows? He says, no, I've actually got 16 rows. Okay, well, here, give me all 16. I'll wait until you give them all to me. I'm going to build a hash table. Once my hash table is complete, I'm going to come down here to the nested loops value and say, hey, on my first hash value, do you have any matching rows? And then it goes to the clustered index seek and retrieves a row. It goes to the hash thing. It goes back over here in the compute scalar operator. The compute scalar operator says, do you have any rows? Well, compute scalar operator is like, hey, man, all I do is calculations. So it goes to the nested loops join and says, do you have anything? So I don't know. Let me check with the index seek, and the index seek, on and on and on until it gets down to here to the key lookup. 93% of the estimated cost, possibly a tuning opportunity. Who cares? Heading back up, it's returning all the rows. Did these compute scalar operators occur at these precise points on that row as it first went through this process? We don't know. Is it likely that that calculation of subtracting one column from the other occurred at the lookup or immediately after the lookup before passing on to nested loops? Yes, probably. That's where it occurred, but we won't know unless we look at the optimizer. Now this is not a bad, evil thing, but this is one of the places where the internals that are exposed to us are not accurate. And that's why I like to bring it up, because it's something we need to keep an eye on. Any questions on this one?
Yes.
Persistent columns, does that affect the calculations here? If you have persistent calculations within your views or in your tables?
It completely depends on the calculation itself. Without knowing the calculation, I couldn't tell you. In this case, this trivial little subtract this column from that column calculation that it's doing, nah. That can't possibly affect anything. If that's affecting stuff, we got problems, right? We have a lot and bigger problems than just that calculation.
Cool deal, thanks.
Cool. Well, let's talk about the next topic: constraints. Now, if you think it's easy to tie yourself up and do a selfie, you try it. It is hard. Just so you know, the whole idea on constraints is that they're going to affect inserts and select the most. And it really does all come down to trust. And the values that are trusted affect the behavior, and the values that are not trusted do not affect the behavior of execution plans. So let's take a look at what that means. So we're going to do an insert into this table. And the reason there's rollbacks is just so I can do these things 100 times and never have to worry. Oh, doggone it. The insert statement conflicted with the check constraint. Check ship method ship rate. All right, well, hang on. Let's just take a look at the estimated plan. I still hate using that terminology, but it's the only one we have. Now, if we take a look at the estimated plan, once again, for an insert, we have a constant scan. We already know what that's doing. It's creating some value for us. Then we've got a couple of compute scalar operators we'll have to take a look at. We've got the clustered index insert, and then we have an assert, an assert value validating that the stuff we just added is correct. So let's take a look at these compute scalar operators to see what they are. Now this one is just getting the identity. So cool, we know what that does. We know why that's there. We talked about that earlier. What's this one doing? Oh boy. Expression 10,003 is equal to the scalar operator, convert implicit, in varchar 50 at 1. Expression 04 is equal to scalar operator, convert implicit, money at 2. Oh, I know what this is. This is setting up all of the columns and validating that all of the data that we're passing in. And we also have the new ID operator, and we have a get date operator. And we can validate all of those by going back and looking at the code real quick. Cool. So none of these has anything to do with the check constraint. So what's our friend the assert doing? Let's take a look. The assert is doing our work. Case when ship base is less than or equal to 0, then 0. Else, case when ship rate is less than or equal to 0, then 1, else null, end. This is our check to validate the ship base and the ship rate values are greater than 0, because there is a constraint on the table that's preventing these things from running. That's preventing these things from taking 0 base values. So again, within the execution plan, we can see how the optimizer is resolving these things. Also, by the way, once more, the identity value is created first. The assert, which is going to stop or start our inserts, is second, and this is how we lose identities. And we can see this in process going on. So now if we try it this way, if we make sure that we're passing in valid values, let's execute it and capture the plan. It's still erroring out. Why? Well, because I've added a ship rate, but I didn't change the ship base. So what we could do, I mean, these are the definitions. What if we change them? Now, this is how we add them. Let's do this. I don't know why I've got it up there like that. Let's drop the ship base connection. There we go. And now let's do the same insert again. Actually, this is a horrible insert, even worse. Oh, it's still messing up on ship rate. Supposed to, hang on. Never type in demos.
Is this some sort of secret SQL prompt demo?
Yeah, it was just so I could demo SQL prompt. That's all it was. There we go. Now let's run this. No. Shouldn't interfere with ship rate. We just took it off. I just removed that constraint. Didn't I? I guess I didn't. Wow, I'm on drugs. Okay. Weird. So you can see that I can just add these values in, and we can take a look at the execution plan. There's no more assert because there's no more things in there. But what if we do this? What if we add them back in without using the with check? We've got constraints back on. What? Oh, those are the default values. This is all going south. Come on, what's going on? Oh no, that was it. That was all I wanted to show on this one. Okay, cool. Yeah. That was all I wanted to show on this one, because the select one's where the fun starts happening. Hang on, let me cool. Now I'm gonna have to do the same thing. Oh well, I'll fix it later. Don't worry. I'll restore it or something. I'm not gonna hold you guys up while I clean up my mess. Now, if we take a look at this, good. That's still doing the same thing. Let's take a look at selects. If we run this select statement, let's take a look at the execution plan. All right, cool. It brought back all these values, off it goes. No. Okay, cool. That was the wrong one. Take a look at this execution plan. It brings all our values. We get the thing that we expected. Sorry about that. I'm going to clean that code up. But if we run this execution plan, hang on. Let's try both again. So it's returning all the values here, and we can see it's returning. There's rows, there's actually data in the table. But here, what are we getting? We're getting a constant scan. Let's take a look at the output list. And what's the output list? It's a set of columns. It's the columns that we have defined in our query. Well, what's going on? Well, what's happening is this table has a check constraint on unit price. So if we drop that check constraint, and this is where we were supposed to drop the check constraint, by the way, if we drop that check constraint, and now we run the query, see, we actually get an execution plan, a very different execution plan than what we had before. Why? Because there's no values that have under 0, because there was always been a check constraint there ensuring that no data gets in. But the select statement that we run with the check constraint, as long as it is run with check, you'll notice I just ran it with no check. Oops. The query's still working. So even though, oops, there we go. Even though we've put a constraint back on, because we didn't have it trusted, because we didn't put it in with check, it allowed us to run that query again. So now let's just clean things up. Any questions on that one? I love that bit where the optimizer returns no data at all. Just a little thing defining the columns, because the query that you put in just isn't going to work. That's a fun one. Nothing but a constant scan. No, you guys are good?
We're good.
Awesome. All right. Merge statements. I'm not going to go on a crazy diatribe about merge statements. What I am going to say is merge statements get compiled the first time you run them. And that, depending on the merge statement, could be hyper problematic depending on the query. The problem we get with merge statements is that even though, you know, this, I promise you this was not going to be about query tuning, and we do keep talking about performance, the fact of the matter is that all the queries that we run, the choices that we make on data structures and the code all do affect performance, and they affect the choices the optimizer makes and how the optimizer makes those choices. And the thing I find with merge statements is they just don't give us tuning opportunities. I'm not anti-merge statement because they are in fact handy. So if we're going to create this procedure. It's passing in a bunch of values and it's doing a merge. And so it's taking a look at those values and says if they're not matched, insert. If they are matched, update, and when the source quantity is 0, delete, right? A nice, simple, straight up merge statement. This is how it was designed to be used. You guys watch me create it brand spanking new. So this is the first time we're running it. So I'm going to run the plan, and we're going to run it for an insert to add some data. So we're going to execute it, and then we're going to capture the execution plan. And you'll notice pretty quickly, oh, come on, get back over there. I have got 3 execution plans. I've got the merge execution plan. I've got the insert, I'm sorry, 4. I've got the merge execution plan. I've got the insert execution plan. I've got the update execution plan. I got the second update execution plan, the third update, 4th, 5th, 6th, 7th, 8th. What the heck is going on? Well, there was a lot of data in there and it kept going and it kept trying to do all of these. So doing the actual plan in this case is horrible. We won't do that again. Let's just take a look at the estimated plan. Now things get a little easier. I've got the merge statement coming in. It's showing me an index update based on a table spool. And in short, it's recognizing that there's probably the data there. It's probably going to be able to do an update statement. Okay, cool. Let's take a look at, let's pull the plan out of cache. Let's do a straight update statement. Oops, idiot. Not supposed to look at that. Did that once. You're only supposed to see that once. There we go. Let's take a look at the estimated plan again. And you'll notice the estimated plan is exactly the same. Even though we forced a recompile, even though this is an update instead of an insert, it's the exact same plan. Okay, fine. Let's pull it out of cache again. Let's run the delete. Oh, I keep forgetting. I get in the habit of executing the queries. I got to remember. And you'll see it. It's identical. It's the exact same plan yet again. Now, this is the entire point of this bit of the demo, is that there's so little control here. And it's not that I'm against these things, but they behave in a way that we can't do the kinds of things that we're used to doing. We get a lot of stuff going on that it's a lot of work. I mean, it's creating table spools to manage the data. There's all kinds of things going on in here that we wouldn't normally have to deal with in a traditional, if it's an insert, do an insert. If it's an update, do an update. If it's a delete, do a delete. We get a very, very different set of behaviors with the merge. And there's very little control we get over them in the way that we can control each of those individual queries. And the main reason there's so little control is, let's go back and do this. Let's remove it from cache one more time. Don't break the code, Grant. Let's add it. Okay, cool. Hang on, let me just turn this off. Let's delete it. And even though we're rolling back the transaction every time, it doesn't matter. Because we're still getting execution. And let's delete it. And then let's just see how often this thing's been called. And the fact is it was called 3 times. It gets compiled and it gets reused. Now that in theory is good, but a delete statement doesn't need all these other values in it. And it doesn't add anything. All it really cares about is the fact that, give me the ID, the sales order ID. I'll delete what I need to delete. It gets compiled though up here when it's not deleting data, and maybe this value is not the same. And that the fact that it's created for this value means it still goes through parameter sniffing and all the rest of that stuff. And you could get plans for the delete statement that are no good, because when it was created back up here at the insert or at the update, wherever it got created, it's going to be different. And therefore, you have a lot less control. And so that's my biggest pushback on the merge. Are there other issues with it? Sure, there are. Is it a nice way to do code? Yes, it is. It's actually a nice, simple way to do code. But when we start talking about performance tuning, there are problems here. And those problems are most evident for me through the execution plan. Any questions on that one?
Yes, there's a question.
Cool.
Grant, even though you flushed the proc cache on the plan, is this thing still saving the query hash? And reusing that?
Is the data still up there? Yeah, it could be. Yeah, but it wouldn't matter because the well, I mean, in this case, probably no. In this case, probably not, because what we did was an insert, update, and a delete. So it's probably not. Whatever data is up there in cache, it wouldn't be retrieved in the same way. But that wouldn't matter for terms of the execution plan. We pull the plan from cache; it has to recompile. But you'll notice the plan was the same every time. And that's partly because I forced it to be. Like, I didn't have to, I could pass in dummy values for these things, because all I really needed to was to pass in the order quantity of 0 to make this thing delete. But what I did was I set them up so that order quantity here is 1, order quantity here is 1. I passed in the same parameters each time, so it would compile the same way every time. I cheat.
Looks like that was the question.
Okay, cool. All right. So, triggers. Triggers are fun because triggers are hidden behavior. It's even in execution plans, triggers are hard to see. They've got their own little execution plan off running on the side. It's completely different. So it's doing whatever it does, and you can't always see it. Where you really can't see it is when you look at estimated plans. They are invisible at that point, triggers. And you'll notice I've used estimated plans several times tonight because I like using estimated plans. They're handy. You don't have to run a query to get good information. Yeah, I do like running the queries. I like getting the runtime stats, but you don't always have to do it. But as soon as you introduce a trigger, again, all hell breaks loose. So let's take a look at these. So I'm going to create a trigger. Going to do some horrible stuff. A lot of horrible stuff. Okay, even more horrible stuff. Awesome. Ah, good. I already created this heinous thing. All right, so if we do an insert, right, run the insert query. Let's take a look at the estimated plan. Well, I mean, it ain't pretty, but it's actually fairly readable. We understand what's going on based on the other stuff we've seen today. There's a constant scan, a compute scalar operator. So what's that doing? Creating our placeholder for data to be added. I'd be willing to bet you money without even looking at it. That's going to be the identity column. This is probably the definition for the columns being passed in. We see a clustered index insert. Then we see a whole bunch of other queries running to validate everything. It's sequencing things to make sure they all come in together. This is a fairly complicated query, the whole bunch of tables involved. And so it's bringing back all this information. Cool. Now let's run the query and capture the plan. Uh-oh. That didn't... Should work. There we go. So now in this case, what you see is that I've got two plans. I've got a second plan down here. What's this plan doing? This plan is a trigger. The insert fired off a trigger, and it's going in there and doing XML and pulling data back to retrieve this stuff. And it's using the sequence operator to ensure that this stuff occurs first, and then this stuff occurs second. And it's creating table spools to retrieve that data and move it over to here and then load that stuff up. And the way I can tell that, by the way, is the fact that there's a primary node ID. And if you see the primary node ID, then the next thing you want to do is do a search, find node, node ID is equal to 2. And there it is. So there's our node ID 2. So when you've got a big plan like this, you can track them down pretty quickly. And so now we know that the data from here off on the right is loaded into this table spool and then used down here for the trigger. And so that we can see. But if we take a look at the estimated plan only, it goes away. Oh, wait, no, there it still is. What the heck? That's wrong. Unless they've changed behavior on me. Huh. Interesting. Oh, I'm on the wrong demo. That's the identity column demo. We already did that. Okay, other than the fact that Grant's demo didn't work right, are any questions?
Yes.
Yes.
Yeah, no doubt.
From the execution plan, is there something that will specifically tell us that what we're looking at is a trigger and not part of the what causes the trigger to fire off?
Well, what we should be seeing here, I shouldn't be getting a foreign key constraint. This is making me upset. I got to double check this code now. But what we should be getting here is the insert should work, even though, well, the insert should work. And then what I should get, that's so weird. I should see two execution plans, distinct execution plans. And so that's how you can tell that you've got something else going on. When you're looking at, well, I've got an insert to a table, there shouldn't be anything else. All I should see is the insert and the table. It's when you see a second execution plan in there that something's up. I don't know why this thing is doing the business entity. I'm not going to try to... That business entity 0 is causing the problem. I don't know if I can guess at a value or if I'm going to go in and dig and find something. Let's try it, see what happens. Nope. Can't insert duplicate key. Oh, I may have run this test before without the rollback. Duplicate key value is 42. Hang on, let's try this. Yay! Second execution plan. And you remember all of the horrors that I did on that execution plan, all the horrible things I did? Here they all are. So this is a second distinct execution plan with all that nasty stuff running. And that's how you can tell that you've got a trigger going on, even though this is a single insert into one place. There were actually multiple execution plans. Yay, I'm glad it worked, finally.
Well, let's say that I'm automating and doing some automated analysis, statistical analysis of what's going on from the execution plan. Is there something within this secondary execution plan that says I'm doing this because I'm triggered, or because I am a trigger?
You know what? I don't know.
You know,
Let's take a look.
I mean, we can look at it and see, but if I'm doing something that's automated, I can't necessarily look at it. That's why.
Right. Well, so I mean, this is my insert. This is my insert. So that's occurring. This is an update. This is a trigger. I'm curious now. You asked me the question, and now I need to know the answer. My assumption would be I would see it here in the properties of the first operator if it was a thing. And I honestly don't know. I knew that we were going to get multiple plans, but I don't know if it's going to mark it in some way.
Or the name of the trigger, or
yeah, I know. No, I don't think we're seeing it. All we're seeing is the code. It's doing multiple, and oh, by the way, could not generate, oh no, valid parallel plan. It's doing multiple plans, but that's all we can tell, is that it's doing multiple plans. Huh, interesting. I don't know. That's something to track down. Thanks for asking.
a secondary question, a follow-up question.
Now, by the way, I can tell you how you can tell, and that's in the DMVs. There is a triggers DMV, and you can use the triggers DMV to join against the execution plans DMV, and then you can pull back the execution plans for triggers that way.
Mike, you had a question?
Yeah, there was a follow-up question. I interrupted, but go ahead.
Sounds like you answered the follow-up question.
Oh, cool. Yeah, sysdm exec, sysdm exec, sysdm exec trigger stats. Yeah, God, that was way too easy. That's why I couldn't remember it. Because there's sysdm exec query stats, sysdm exec procedure stats, sysdm exec function stats, and sysdm exec trigger stats.
Looks like those are the questions.
Okay, cool. All right, that was triggers. Thank God I got it to work right. Identity, we started by accident. So constant scan, assert, and gaps. Now, we've already explained about gaps earlier on. I always forget that I'm going to talk about identities and tell you guys the answer right at the beginning of the entire presentation. But let's take a look at sequence operators. If I run this to set up a table with a sequence operator and a constraint, I can also run several inserts. And one of them, you'll notice, had a constraint issue. It saw a problem. But if we look at it, what we get is the same behavior on sequence objects. We get a constant scan followed by the definition of values, which it's getting a sequence next. And you see it's from my sequence generator. Then the compute scalar operation, which is doing a convert implicit to make sure it gets to the right value, the insert, and then an assert to validate. And so two of them worked, one of them failed. That's why we only have 2 plans instead of 3. But you get the idea here. The operations for a sequence, except for the fact that it's not doing, at the compute scalar operator, it's going to my sequence definition. The actual behavior is the same. And the reason being is that when Microsoft when they created the sequence operator, they actually killed the internals for the identity operator and sort of just duplicated the code for sequence. So that's why you're going to see not identical, but really, really close behavior. Any questions on that one? You can see the results that come back. Dude and something, and dudette failed because passed in a value that wasn't valid. And that's also, by the way, how you would get gaps in a sequence. If you look, we're looking at 1 and 3. Same concept. Any questions on that one? Okay. If not, we're going to talk about my favorite topic in the world. I hate them. Multi-statement, table-valued, user-defined functions. They are evil. They are just abject evil. They are all things evil. What they represent is code reuse, and they look attractive. If you read a lot of philosophy and stuff, Satan was the beautiful angel, right? The prettiest one, and evil. And that's what these things are. They're pretty. They look pretty. The multi-statement table value user-defined functions look like object-oriented programming. And so I had a team that they went off and they found these things, and they created multi-statement table value user-defined functions that called multi-statement table value user-defined functions that joined to multi-statement table value user-defined functions with nested multi-statement table value user-defined functions 86 layers deep. It was the most beautiful crystalline structure you've ever seen in your life. They turned SQL Server into an object-oriented programming. It was gorgeous. And it worked just fine in dev with one row. As soon as it hit production, where we had millions of rows, it stopped. And no, I don't mean it took a long time to run. I mean, we let it run for 3 days, the first query, and it never returned, so we killed it. And the rollback happened instantly. So it was still just sitting there processing. It had never actually moved data. It was horrible. Now, these are distinct from, and not to be confused with, scalar functions or inline table functions, also called parameterized views. Scalar functions are not evil, although like anything else, you can dig a deep, dark hole with them. Inline table functions are not evil. In fact, they are extremely useful, although you can, like anything else, dig a deep, dark hole with them. But multi-statement, table-valued, user-defined functions are evil. And what's worse, inside of SQL Server, they are secret. They are hidden behavior, and let's take a look at it. Now I've got a user-defined function. This is Microsoft's. If we take a look at the execution plan, it's nice and simple. It's no big deal. These things, there's nothing to it. It's a table-valued function, UDF. It's got a sequence operator. Sequence operator just ensures that everything's processed in the same order. So it processes this, then it processes this. And that's all. It returns one row. What is the big deal? Well, here's the big deal. Let's take a look at the estimated plan. Oh, good God. So is this thing doing, what we had was this little function and this little table scan and return one row. What's actually happening? Well, it's got a conditional query, and the conditional query is deciding which one it should do, and then it creates this plan for one condition, this plan for another condition, this plan for another condition, and this plan for the final condition. In other words, it's creating multiple execution plans for this function, all based on the values you passed in. Oh, wait, no, not based on the values that you passed in. What are each of these things saying? Estimated, how many? Hang on, let's get it up here. Estimated, 1 row. How about this one? How many rows are estimated up here? Come on. I hate tooltips. They never work when you want them to. They get in the way when you don't. 1 row. Everything is 1 row. Why? Because it estimates all of this stuff off of 1 row. Now, 2017 and 2019 introduced the adaptive execution plan, the plans that can change on the fly for the multi-statement table value user-defined function. And that fixed everything. Yeah, okay, I'm lying. It made things slightly faster, because what it will do is it does interleaved execution, and so now it will go through, and as it runs, it'll go, hey, you know, we're actually getting more than 1 row, we're getting 20. We probably should change, stop, compile a new plan. Oh, wait, we're not getting 20 rows, we're getting 5,000. Maybe we should stop and compile a new plan. You know what? That's good enough, we'll just leave it alone at that. It's horrid. But hang on, let's take a look at what goes on. Now, here's what normally happens. We get this product list function. Okay, cool. It's joining pulling some data from the product tables, joining those together, off it goes. Great. Let's run it. Now, if we run this query, select star from product, the execution plan, it's key lookup. Maybe there's some tuning opportunities, a little scan there, and off it goes. Oh, and by the way, a table valued function. Well, the table valued function is no big deal. It's just using this little scan, so it's for bringing stuff back. But once again, let's take a look at the estimated plan. Oh, this little thing up here is this down here. And yeah, we already saw, I mean, you saw me create it, so you knew that it's going to be doing more work. But it's doing clustered index scans, multiple clustered index scans, which are not visible here. This is the key to these things. They are not visible. And oh, by the way, remember how they fixed the whole plan estimate so that it would never estimate more than 100%? Nope, still doesn't work. They still have never fixed this right. It makes these estimates and it goes over 100%. It's a horror show. And this is a simple example. Now, if we took the same query, because this is the same query, believe it or not, and we run it as a query, not trying to do code reuse, but just run it as a query, it's a series of index seeks with nested loops. It's very neat query. If we write queries, we are frequently better off than attempting to do code reuse. And that's just a fact. And we can get into all kinds of fun stuff with this. I can nest these things. I've got all kinds of fun things we can do with it. But hit me. Are there any questions around it?
There's murmuring, but no questions.
They're just evil. I mean, and the thing is like the new things that Microsoft's doing it with, it made them a little less evil, but not crazy so. By the way, this is an inline function. You see how it resolves to a normal execution plan? These things are fine. I have no problem with inline functions. Or sorry, that's a scalar function. They're fine. This is an inline function, and we can run it as an inline function. Here, let's go ahead and do it. There's no hidden behavior for these things. They resolve as normal queries. Now, whether or not there's tuning opportunities here, there are, but that's not the question. The question is can we see the behavior? And we can very easily see the behavior here. We don't have to go, I mean, it's almost like the anti-trigger. For triggers, you have to go to the actual plan to see what the heck's going on. And for multi-statement UDFs, you have to go to estimated plans to see what the heck is going on. So it's all crazy. No questions? Okay, cool. I'm going to skip this one. In-memory store procedures. Is anyone in the room using them?
Not stored procedures. We're using memory optimized table types and a couple of
right
tables.
Are you using what table variables?
Yeah.
Yeah, they're cool. No issues, no complaints. They're cool. In-memory store procedures, the execution plans, and this started in 2016. It continued in 2017, and now in 2019, it's exactly the same. I'm tempted to take away bullet number 2, saying it will change. It won't. The execution plans are outright lies. They tell you that it's nothing but index seeks and nested loops joins. And you can write the most heinous query in the world, do horrible stuff that there's no way the optimizer is figuring it out so it can do an index seek and a loop join, but that's all you'll ever see in the execution plan. So it's just a lie. Don't believe it. All right. Live execution plans. Have you guys seen this before?
See people shaking their heads no. I've seen it, but apparently a lot of people have not.
All right. Come on. Oh, wait. It's because I got the actual execution plan on. Hang on, I got to turn that thing off. There we go. Okay, fine, I'll do it this way. No, come on. That's an active, expensive query. It's running, still running, for crying out loud. Okay, fine, we'll do it the other way. I'm easy. And you'll see this query is just heinous, by the way. Ooh. So this is live execution plan. Now, they've made a bunch of changes to them. There's these things called lightweight statistics, and it's either a trace flag or an extended event. You can run the extended event and then you'll get lightweight statistics, or you can turn on the trace flag and you'll get lightweight statistics. But with those enabled, it will allow you to capture these things on the fly. You won't have to just run the query like I just did. You can actually capture them on the fly. This is not always going to be the greatest thing in the world. It's only going to run on long-running queries like we have here, but it does give you at least an estimate of what's going on, and it can give you an indication of what's happening. Now, in the case what I have here is I've got a really bad query, no join criteria against a whole bunch of tables, and I'm bringing back everything. So it's just a really stupid, badly written piece of code, but it allows me to run it so you guys can see the live execution plan. It's just another little demo. This isn't really the most exciting of the stuff that I do, but it's so pretty. I like to share it.
This is just based off of setting the profile on statistics.
You can do the lightweight statistics with a trace flag, or there's an extended event that you turn on, or you do what I did, which was capture the live plan. But to capture the live plan, you actually have to set it up before you execute. If you have the trace flag or the extended event enabled, you can just go in and capture the stuff on the fly.
Could you turn this on and off dynamically?
Well, yes, you can turn it on and off dynamically, but if a query is already executing, it won't matter.
Fair enough.
So you can't go like, oh gosh, I've got a long running query, turn it on and try to capture it. You can't do that. You have to have it on already. It's extremely lightweight. A lot of people I know that have queries that run like this are turning it on and leaving it on, and it doesn't add overhead except when you're monitoring it. I mean, it adds some. I mean, right, like I said, nothing's free, right? I mean, everything comes with a price, but overall, it's fairly cheap.
Where is the data being collected?
It's live against the DMVs.
Okay, thank you.
Sure.
What was the purpose of the statistics profiler on? What did that do for you here?
That was old code. You notice I didn't use it.
Oh, okay.
Nah, it didn't do anything. All right. So, in conclusion, hopefully you guys got the idea that this isn't just about query tuning. Yeah, everything kind of circles around to it eventually. And a lot of the stuff we talked about was at least query tuning related, but it's mostly about functionality. And it's the idea that we can observe the behavior, not simply of, did I get a seek or a scan, but what the heck is SQL Server doing inside? What choices is it making? How is it making those choices? And how is that stuff being resolved? We get to see a lot of it. Thing to remember though is it's not all of it, because some of it is hidden. Like I talked about with the compute scalar operators being, just done wherever it's convenient by the engine. It's not necessarily a true representation. It is just a representation. For additional resources, I recommend picking up my book. This is a slightly old picture. There is a third edition out, and don't ever read the second edition. The guy who wrote it's an idiot. The third edition is really good. Also, Fabiano writes some amazing stuff. Rob Farley is, he can be irritating, but he's amazing. Also, Paul White has drawn back a little bit, but even his old stuff is still extremely useful. Now, if you guys want to get in touch with me after today, this is my contact information, grant@scarydba.com. I answer my emails. That's my Twitter handle and my blog. And feel free to reach out. I'll take any other questions we have now.
Any questions, anyone? Go ahead.
Just for my benefit, since this is the advanced DBA group, this is my first time coming because I come to the other. When you say you don't want to write most of your queries, you mean you're using a query builder, or can you just explain that in your own words, or you really shouldn't be writing all your queries?
Well, because most of your queries, most of them, not all, right? And we need to be very emphatic about not all. But most of your queries are stupid, right? Insert into table. Should I have to go to 400 tables on 200 databases and write, however many, how is that, 8,000? 8,000 insert statements? Probably not. Delete statements, pretty stupid. Probably don't need to write those. Most, but not all, select statements, pretty stupid. Let the code handle that. Entity Framework or in Hibernate or some of the other code generation engines can generate parameterized queries that are perfectly fine. Now, about 5 to 10% of the queries they generate are not simply less than fine, they are utter crap. But that's fine. Let's identify that 10% and write that code, because that's going to be the painful 10% anyway. So we focus on the 10%, we let the 90% slide, and our lives get a little easier because that 90% is going to be right, because it's generated the same way every time. If we identify, some little pattern that's bad, we change the code, the pattern goes away, life is great. In my own words, that's my take. And I've had experience. Now, here's the deal. If we are talking about building a database and then generating code, works great. If we are talking about letting the code build the database and generate the code, no, it doesn't work at all. But that's totally different. I really always emphasize I'm talking about queries. For queries, let the code get generated. It works really well.
What about link queries? Is there a similar analysis that you've done or seen done for the.
Yeah, this link is the same. I've had great experiences with link queries, working with dev teams that are, aware of the fact that link does a great job 90 to 95% of the time. 5% of the time, it does junk. The developers, after a while, the developers get good at spotting when it's going to do junk, and they just immediately, they either write the query or contact me. But that's working with decent development teams. You work with crap development teams, and they're like, nope, we will never write T-SQL ever again. Link can do everything, and the fact is it can't. And when it goes bad, when it hits that hard hump, it doesn't go simply a little bit bad. It's not like your junior DBA wrote a crap query. It goes stupid, insane bad. I mean, I've got another set of code examples on bad link queries and bad, in Hibernate and bad entity framework. I mean, they generate heinous code, but most of the code they generate's not. And so my take has always been, the same on almost anything we do. I'm lazy. How can I do the minimal amount of work? Well, I'm going to let them generate 90 to 95% of the code, and then I'm going to capture that 5 to 10 that I need to work on, and I'll work on that 5 to 10.
How do you make the determination of which 5 to 10% you have to work on or should work on?
Generally, I monitor what they're doing. I set up extended events on the development server, and I watch what it's doing. And you pretty quickly, not pretty quickly, almost instantaneously can spot, oh, look at that. What's that? Here's clearly a bad piece of code. I mean, because when you're on a dev machine, or an integration server or a QA system, and you've got a query that's running, 30, 40, 100 times slower than all the other queries on the system, they stand out real fast. And, so you go in there, you pop it open, you take a look, and it's like, okay, here's where I need to spend my time. Now, sometimes it's the developers wrote some bad code. They didn't tell in Hibernate or Entity Framework or Link, they didn't tell it what to do correctly. Sometimes, but sometimes it's just Link.
Thanks.
Any other questions?
Well, cool. Hopefully this was useful, and I don't know what time we were supposed to end. I wasn't even looking at the clock, so if I went long, you guys should have yelled at me.
This was good.
Okay, cool. Thanks. Well, thank you. Hopefully you guys got something out of it.
Thanks so much, Grant.
Not a problem.
As we wrap up tonight,
Thank you again for dropping by. Remember SQL Saturday Raleigh, April 18th. Sign up at SQLSaturday.com/981.